Good morning to everyone. This is Dr. Polaiah, working as a professor, the Department of IT at Institute of Aeronautical Engineering, Hyderabad. So today I'm very glad to all inform that our topic is the introduction of color image processing. Introduction of color image processing. So it is one of the topic which we had to concentrate from our syllabus, from our subject. The name of the subject is, everyone knows, that is image processing. Okay. So under the image processing, we are all concentrating introduction of color image processing. Okay. So you have to concentrate this color image processing. How? In the sense, basically, being we are students, or being your technocraft, towards to concentrate this development of image processing. So we have to keep on that, at least to learn some fundamentals. Some fundamentals. So what are those fundamentals we are going to be concentrate? So let you see there the fundamentals which we want to concentrate as much as syllabus that are here. Color image processing syllabus which we are here, we are going to be concentrate color models. Okay, pseudo color image processing, basic of full color imaging processing, color transformations, smoothing and sharpening, color segmentation, noise in color images, color image compression, which we are going to be connected further color image processing by the help of wavelets, multi-resolution processing, image pyramids, subband coding, Hall transformation, multi-resolution, expansions, wavelet transforms in one dimension, fast wavelet transformations in two dimensions, wavelet packets that are fundamentals in image compression models, free error that are lossless compression, lossy compression. So these all we are going to be concentrate complete syllabus. What is this syllabus which we are going to be understanding here, as a fundamentals, as much as a fundamentals. By using this color image processing syllabus, we are going to be concentrate for the understanding of 100% basics of color image processing. Okay, so how we are going to be concentrate there? So we are going to be understand one of the topic which I have taken from the syllabus. One of the topic which I have taken from the syllabus, that is called color models. Color models. So what does it mean to understand about this color model? What does it mean to understand about this color model? Color spaces are different types of color models used in image processing and signals and system for various purposes. Okay, so we are getting that type of color model in terms of some of the common color spaces, or some of the common color spaces are number one RGB. RGB stands for red, green, blue. So how you are going to be here understanding about red and green and blue. So what do you want to understand from here about this red and green and blue colors? So from this we are going to be prepare your image. That is, for example, your image is right now called as color image. In the sense, this RGB are being attained in terms of color models. Okay, so that means the difference between RGB and RGB, that means color models image, and you are going to be differentiate from the grayscale image. This is RGB image, that is grayscale. So what you want to understand, the color model which we concentrate on the some common spaces are in between RGB or image. Whereas grayscale we cannot. It cannot be applicable. It cannot be applicable. So that is the very important here. Okay. So next coming to the another model which we want to understand, CMYK. What is that? CMYK. What do you mean CMYK? It stands for KL, Magenta, Yellow and Black. So here C means KL, M means Magenta, okay, Y means Yellow, and what are these CMYK? K means key, that is black key, which we are going to be use the one of the color model. Again, this model we are going to be used to concentrate on to differentiate in between your RGB as well as grayscale image. RGB as well as grayscale image. Okay, so that means your HSV, coming to the another model that is called one of the color model is simply we say HSV. So what do you mean to understand about HSV? H means histogram equalization, converting to the grayscale images. So we are going to be concentrate here. This HSV is the more and very important whenever we want to concentrate on conversion from the grayscale image to color images. So you can understand this model is more applicable to the black and white movies, black and white color, black and white photos, which are olden days and all. The camera which they are prepared basically as a black and white camera. After that, they changed the technology based on that updation of the technology. We got the color photos. So now we are concentrating how we can convert from black and white to color. So by using these color models. So among this color model, one of that HSV is the model which help us towards to convert from grayscale image to your color model. I hope you got it my point. So what do you mean to understand about HYK? It is another type of model. It is another type of model which we want to concentrate here. HYQ. What do you mean here HYQ? Let to introduce about HYQ. Y stands for luminance part. IQ stands for your chrominance part. I'll repeat for understanding about IYQ. YIQ. Understand? YIQ. Y stands for luminance part and IQ stands for chrominance part. So this is one of the color model. One of the color model, where this color model is used for the sake of towards to develop your image in the form of color models. You can use one of the YIQ color. Next, coming to the, we are going to be understand the continuation of color models. Here we are going to be understand one of the topic which is we can understand under the color models, achromatic versus chromatic. Achromatic versus chromatic. What is this? What will do the major job this? This also will concentrate on to prepare for the sake of development of color models. Okay. So how can you concentrate here? Achromatic light. Why achromatic light is the one which we are going to concentrate here about to prepare your color model in terms of void for color. Only attribute is the intensity measured by gray levels. For example, black and white TV. The kind of images that we discussed so far from the previous slides. So chromatic light wavelength is the around 400 to 700 nanometers. wavelength. So the three basic quantities are used to describe the quality of a chromatic light source. Chromatic light source. Chromatic light source, how we may be concentrate towards to understanding, to improve the quality. To improve the quality based on the three basic quantities are used in terms of quality of a chromatic light sources. Next, whereas under these chromatic light sources, we are also going to be concentrate one more important part of this chromatic light source is radiance. The total amount of energy that flows from the light source in watts. So, what do you mean to understand radiance? Radiance is nothing but total amount of energy that flows from the light source in terms of watts. So we are extending here about this chromatic light sources, not only radiance but also we are concentrating on luminance and brightness. Okay. So what do you mean to understand about luminance? What do you mean to understand about luminance? Luminance means amount of energy and perceives from a light source in luminance. For example, far infrared light has large radiance, but an observer would hardly perceive it. So, what do you want to understand from this? Here, infrared light has a large radiance, but an observer would hardly perceive. So next, coming to the important aspect here, the brightness. Brightness means similar to the chromatic notion of intensity. Once of intensity, uh, one of the key factors in describing color sensation. Color sensation. So your image is now RGB image. Okay, in this RGB color image, you want to improve the brightness. You want to improve the brightness. How? How can you improve? By applying the chromatic notion of intensity. By the concentrating on chromatic notion of intensity, one of the major key factors in the describing color sensation. Color sensation or color differences here is red to green, green to blue. So you are wearing these all three colors one to other based on your required brightness. Next, coming to the your color models. Basically, we want to understand towards to prepare in terms of primary color versus secondary color versus of a light sources. Okay, how we maybe says about primary color sources versus secondary colors of light source in the sense, right? So primary colors versus secondary colors of light, that is primary colors are red, green, blue, noted as the RGB components acting alone cannot be generate all spectrum, cannot be generate all spectrum colors. So we'll keep only RGB components. We'll keep only RGB components. Only RGB components. Okay. RGB components acting alone cannot be generate all spectrum colors. Understand? So secondary colors are magneta, that we called combination of both red and blue. Cane is the combination of green and blue. Yellow is the combination of both red and green. What do you mean to understand here? You are preparing CMY color model. We'll discuss in detail with best examples about tools to prepare such a color model. But you have to follow here about to understand the fundamentals about the color model. How a color model of CMYK we are preparing. Yes, we are preparing such a color CMY color model from the secondary colors, not from the primary colors. Okay, so let me maximizing mixing the three primaries white light. Three mixing the three primaries white light. White light towards to prepare about primary color versus secondary colors of a light, where we are going to be concentrate primary colors versus secondary colors of pigments, whereas here of light source, depending of light source. But we can also differentiate, you can also see the differences between color primary colors versus secondary colors of pigments. Here we are concentrating pigments. So what do you understand about pigments? Again, your CMY, you are going to be prepare your CMY color model, your CMY color model. How we are preparing this? How we are preparing this? That is, primary colors are, as you understood about magenta, cane, yellow. That are we are concentrating about observe a primary color of a light and reflect or transmit the other two, or transmit the other two. Secondary colors are RGB colors. Secondary colors are RGB colors. So what do you want to understand from here in terms of pigments? You are observing in primary versus secondary colors that observe a primary color of light and reflect or are transmit the color other two. So we can change, that is, suppose you have your image, okay, your image is right now RGB and R. You are transforming your image right now to CMYK. CMY and K. How you are transform this? In the sense, your colors are passes in between are primary colors versus secondary color process. Understand? Right, color models continuation. Once again, I am continuing here. That is, RGB stands for red, green, blue, as you know. But here, such a color model is mostly preferably preparing from the RGB model only, RGB colors only. So, what RGB model states that each color image is actually formed of three different images. What are those? Number one, pure red image, pure blue image, pure black image. There are the three color images. There are three different color images. But a normal grayscale image can be defined only one matrix, but a color image is actually composed of three different matrices, because one color image matrix is equal to a red matrix plus blue matrix plus green matrix. That is one color image. What do you mean to understand from here? You are mixing together towards to prepare one color image by the three different matrices. That is, this is one of the matrix. This is another matrix of the image. This is another matrix of image. By the adding of three colors, that means by mixing of three colors, we are preparing one color image matrix. Right. So that is what we want to understand. The main important part of color models which we are preparing from the your RGB colors. So coming to the here, such a RGB colors, I am preparing here your RGB color models. Okay, such a RGB color models which we are concentrating here. Let you see this. This is RGB colors. This is the RGB colors. What we want to understand about RGB colors? R means red color. That is from the previous slide. Let me to show the previous slide. R means RGB stands for red, green and blue. So what do you RGB color model states here? That each color image is actually formed of three different images. What are those three different images? Are number one, red image, blue image and a black image. So by the use of these three different images of colors, we are going to be concentrate a normal grayscale image can be converted into your required color image. It is actually composed of three colors, three different matrices. What are those three different matrices? As I told, one different matrix is we are going to be concentrate on. One is concentrating on red color, another one is blue color, and third one is green. By the mixing together, by the adding together, we will form your required color. See here, your color is here. That is RGB color. We are mixing together. These are you may be seeing here as a black and white. Black and white. Black and white image. So what do you mean to understand here black and white image? In the sense your color right now towards keeping in terms of red. What do you mean to red? So remaining you are going to be keeping on to the changes of other colors. For example, this is red color. I am painting here. This is red color. We will be keeping on red. So what do you mean to understand? You are preparing your color image according to your requirement color models. Now I am preparing here. I want to change the color here is green color. So I can change the color here is by the change of here. What we mean to say colors. I want to change the colors. Otherwise, we will see later. So green color. This is blue color. Blue. So you can understand that the major important point is here by the mixing of your three matrices of the colors, by the mixing of your three matrices of the colors, you can prepare any different color. So that is your very important point. What we want to understand from the RGB color models, you can prepare your required colors. For example, from the RGB, what are we are going to be concentrate so far? We are concentrating on how to prepare CMY, how to prepare HYIQ. So we concentrate that CMY and YIQ models from the RGB only, from the RGB colors, from the RGB. So that is what we want to concentrate about this color image processing. So so far what are we discussed about this introduction of color image processing based on the syllabus, which we are concentrate one of the topic named as color models. That color models are we are going to be prepare the color models. So we are development of the color models for the sake of different applications. What are the different applications? What are the different applications we can concentrate on? Here, number one is medical imaging. Number two is you are going to be quality control system application. Number C part, that is third part is surveillance. Number D, fourth one is you are going to use law enforcement. And next one is artistic, etc. And you may be say etc. It is not be limited. It not be limited. Limited application. Not be limited. Okay. So what we want to concentrate is here is, so your prepared color model is according to the your requirement of applications. Okay. So that is what we want to concentrate of our complete color image processing knowledge is right now we can prepare color models for the different applications. So I'm stopping here by the showing of what are I referred the references are to one are as a prescribed textbooks according to our syllabus. So you can also go through the both textbooks for the sake of understanding about this color image processing. Okay, so I'm stopping here by saying thank you so much for your patient listen, and we are going to continue these color models for the understanding of other topics also. I'm I'm so thankful for all of you for the sake of understanding this concept towards to apply it to the different. Thank you so much. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.